Hello everyone, welcome back. In this video, we'll be discussing about the last problem of today's weekly contest, rearranging fruits. The problem states that you are given two fruit basket, each containing n fruit, and you want to make both the basket equal and you can do following operation as many number of times as you want. The operation is choose any two index I and j and swap ith fruit of basket 1 and jth fruit of basket 2. In other words, just pick any fruit of basket 1 and swap it with any fruit of basket 2. And the cost of this swap would be minimum of the cost of fruits that you have swapped, right? Now the target is to make both the basket equal after sorting. So you don't need to make them equal by just the swaps. Instead, they are saying that you are allowed to sort the array at the end, sort both the baskets at the end, and see if they both are equal or not. So after sorting, you need to make both the baskets equal. And you need to return the minimum number of cost in which you can make this happen. So notice that you don't need to return the minimum number of swaps. Instead, you need to return the minimum cost, right, to make this thing happen. So there are a lot of follow-ups to this problem which we can discuss at the end. But for now, let's focus on this. Let's say is the this is the two basket, right? And now if you swap the first index of this first basket with the 0th index of the second basket, what you will be getting? You will be getting 4122 and 2412, right? So this will be your final basket. And now what is the cost of this swap? You have swapped this 2 with 1. So cost would be the minimum of 2 and 1, which is 1. So in with cost 1, you are able to make both the arrays equal. So why they are equal? Because if you sort this would be 1 2 2 4. If you sort this would be 1 2 2 4, and which is equal. And hence with just cost of 1, you are able to make the basket equal, and hence the answer is 1. So 1 is the minimum cost. There is no other cost possible less than 1 which can make both the basket equal, and hence 1 in the answer. Now how to solve this? So notice that first we need to find out which one we need to swap, right? So in this particular example, uh, let's say this is okay, so this is, let's say, 3, right? Not 2. So here, let's just first cancel out which one of them are equal. So these are equal, so let's just cancel out them. Now what remains is something we need to swap and make them equal, right? Now there are four threes here, right? Or in in a way, six threes, right? Now threes are not there in the second basket at all, right? So let's say instead of this six threes, let's say this one was 2, just for example. Now if this was the case, can you make them equal? The answer is no, because you have five threes, right? You have five extra threes here. You want both of them to be equal. Let's say you swapped these two three below. So these two three now comes here in the second basket. So after these two three comes here, these two three will cancel this, right? Now you will be left with one three at the end, and this one three you can't distribute between both the basket, right? And hence you will not be able to make both the basket equal ever. So this is the first condition that you need to take care of. If the different elements frequency is odd, the answer is impossible. You can't make both the basket equal, right? So in this particular case, with this case, 3 has odd frequency. After cancelling out the common ones, 3 has odd frequency, which is 5. And hence answer is impossible. And even 2, if you look at 2, 2 also has odd frequency, and hence answer is impossible. So if after sorting any element has odd frequency, answer is impossible. You will just return -1 and be done with it. So let's say we filter out those cases, and after filtering out those cases, we now have only different elements which have even frequencies. So in this case, 3 has even frequency, which is 6, and in below, 1 has even frequency, which is 4 here, and 4 has even frequency, which is 2 here, right? So Now the first condition that was there was satisfied. So if this is of even frequency, what you will do is you will swap half of them below, and by doing that you will be making sure that this particular element 3 has equal frequency in both first and the second array. Similarly, you will swap half of the second one above and half of 4 to above, and in this, by doing this, you will be making sure that both of now after sorting, both basket 1 and basket 2 will be of equal, uh, will be containing equal fruits, right? So now what exactly we need to what exactly we need to swap? We need to swap three threes from here, two ones from here, and one four from here, right? So in essence, we need to make this swaps, right? So let's just get rid of this. Now we need to make we need to swap these threes and this two ones and four, right? Now the problem is now reduced to how we will do pairings, like which one will you swap with this, right? So let's say you swap this 3 with this 4, right? So if you do this, what is the cost that you will be getting? You will be getting cost of minimum of basket 1 of I and basket 2 of j. So you will be getting minimum of 3 or 4. So either 3 or 4 will be added to your cost, right? But what you would want in an ideal case? In an ideal case, you would want to skip larger elements as much as possible, right? So you would want the smaller elements to contribute to your answer. So it will never make sense to make pairs of larger elements, because if you make pairs of larger elements, the cost that you will be getting out of it will contain at least one of these larger elements, right? So we want to skip larger elements, and hence it makes sense to make pairs in a diagonal manner. So we will make this 3 swap with this one. And by doing this, what we are saying is we will be able to skip larger elements at all, right? So by doing this, we are saying that we will skip 3 at all. Similarly, we will swap this 3 with 4, and in this process, we are saying this we are skipping 4 completely, and we will be taking 3. Similarly, we will swap this and this, right? And in this process, we will just see the one, or just take the one which have the minimum value, right? So this will give you the minimum possible result, right? So even now, even if you are not completely sure about this, think of it like this. Let's say you have to take half elements from above and half elements from below. Now which one you will take? You will always want to take the first half, right? Instead of taking this, the last half, you would always want to take the first half. And similarly, from below, you will always want to take the first half instead of the last half, because you know the array is sorted. And because array is sorted, you know, if you will taking the last half, this half would be of greater sum than this half for sure. And that's the reason you will be always sticking up with the first half, right? So you can just do couple of uh, examples, and you will be able to reach at this conclusion. So now what we are saying is, after getting out the different elements which we need to swap, we will just pair them up in crisscross manner, and just take the minimum and add it to our cost. Will that be enough? So this will give us minimum cost for sure, no issues in that. But this will only take care of the cases where where we are swapping these two elements completely, like where we are only swapping the elements which we need to be swapped. But in the problem, we need minimum cost, we don't need minimum swaps, right? So we there if there are cases where we can make more swaps but get minimum cost, then also that case would be preferable, right? So in this particular example, what exactly we can done, let's say we are pairing up 3 and 4, right? So let's focus on this part first. So we are pairing 3 and 4. So we will be getting 3 as the output, right? And we are getting 3 as the output because we don't consider other scenarios where we can take help from other element. Let's say there is one x here, right? So you take help from this x, swap x and 3 first, right? So this would become x and this would become 3, right? And then swap x and 4 again. So if you swap x and 4 again, this would become 4 and this would become x. So x would return back to its original position. So there is no change with x, but you have swapped 3 and 4. Now by doing, when you will do this, you will do this only when the cost of doing these two swaps is smaller than the cost of doing this single swap, right? So what is the cost of doing these two swaps? Firstly, you will be taking x, or you will be picking up x which is smaller than both 3 and 4. If it is greater than either of them, then it doesn't make sense, because let's say if it is greater than 3, so why will you take x at all, right? You will always take 3, right? So that's where, like, you will be picking up x which is smaller than both 3 and 4. Now let's say you pick one of such x. Now what is the cost of this first swap where we are swapping x and 3? We are saying that x is less than 3, so the cost of this swap would be x, right? Similarly, what is the cost of this swapping x and 4? So x was less than 3, so x should be definitely less than 4. So cost of the second swap is also x, right? So in a sense, the cost of these two swaps is 2x. So what does it mean? It means that we can take any element which is less than 3, and make swap of any elements in the first and second basket with a cost of 2x, right? Now if this 2x cost is less than the minimum of these two, which is 3, if this 2x cost is less than 3, then we will prefer this 2x cost instead of this direct swap, right? So what can be the best possible value of 2x? So, or in other words, what can be the best possible value of x? So best possible value of x could be the minimum of first or the second array, right? Notice that we are taking both the array to find the minimum. Now why that's the case? Because let's say x is not in the first array. Instead, x is in the second array. Sorry, x is not in the second array. Instead, x is in the first array. In this case as well, you can just swap x and 4 first, right? If you swap x and 4 first, x will come here and 4 will come here, and then do x, then swap this x with 3. So x will again come back to the first initial position, and this 3 and 4 would be swapped, right? So basically it doesn't matter where x lies. X can either be in the first array or x can either be in the second array. So what is the minimum value of x that is possible across these two array? That is the minimum element of both the array. So in this particular case, that is the minimum across both the arrays, which is 1. So x can be 1 in this particular case. So what we can do is, instead of swapping this 3 and 4, we can choose 1 and use 1 to swap 3 and 4. And if we do that, we will be incurring a cost of 2 into 1, which is 2, which is less than minimum of 3 and 4, which is 3. And because that's the case, we will prefer that x instead of direct swapping, right? So hope this makes sense. So just to reiterate, what we have done, we initially cancelled out the equal elements. After that, we said that, okay, whatever is the leftovers should have frequency of even, because if it is odd, you can't uh, you can't distribute them equally across first and second basket, right? Now once we have clarified those cases, we now say that, okay, we know what to swap. We have to swap some elements from the first and some elements from the second. Now we sort these two, and we said that, okay, we have to pair them up. Now the cost is actually minimum of the values of first basket and second basket. So pairing them up would be optimal if we only take the minimum elements in both the cases. So what we are saying is, instead of taking the second half, we will always be taking the first half of both the elements. And how we can achieve that? We can just achieve that by pairing them in a crisscross manner. Now once we have found out that, so in this particular case, we would have paired this 3 and 1, and this 3 and 1, and this 3 and 4, right? So once we have found out the cost from this, This is not the optimal cost because in the problem we don't ask to minimize the swaps. We can do as many swaps as we want. We just need to minimize the cost. So we know that we need to make these swaps, but we are not bound to make these swaps uh, in a single swap. We can use another element, let's say x, to perform these swaps. Now, when does this extra element would be beneficial? Only when the cost that we are incurring currently is greater than the cost that we would have incurred if we have taken x. Now we have shown that x with x we will be incurring 2x cost, assuming that x is less than both 3 and 4. Now what is the best possible value of x? Best possible value of x is the minimum across both the array. In this particular case, 1. Now we will just take 1 and make 1 as a proxy to swap any two elements here. And while swapping these pairs, we will make sure that, okay, what is the current cost? Current cost of swapping these two is 1. So 1 is less than the cost of swapping them with a proxy element of 1. Because if you take this proxy element, the cost would be 2x, which is 2 into 1, which is 1, which is 2. So in this particular case, the cost is 1, but with proxy, the cost would be 2. And hence, you will take direct swap here. In the second case, let's say 3 and 1, the cost would be 1, and with proxy, the cost is 2. So again, you will take direct swap. In third case, with 3 and 4, direct swap cost incurs 3, but with a proxy of 1, the cost is 2, and hence you will prefer 2 over direct swap, or prefer proxy over direct swap. So hope this makes sense. So the pseudocode would look something like this. So we just find out the diffs, right? We find out the diffs, we then sort the diffs, right? And after sorting, we are making pairs of them in crisscross fashion. So diff of I and diff2 of n minus I minus 1, right? Now, this will be the cost, but this will be the cost when we directly swap them. We also have a way to swap them through a proxy, and we know through proxy this is the minimum cost that we can incur, and where min element is the minimum element across basket 1 and basket 2. Now we will just check which one of them is minimum, and we will just take that path. So if this is minimum, it means we are swapping these pairs with the help of a proxy. If this is minimum, we are making a direct swap, right? So hope this entire solution makes sense. Let's look at the code. The code is very similar. So we need to first find out the difference elements, like which needs to be swapped. So what we have done is we we counted the frequency of every element in basket 1 and basket 2 separately, right? And we are also maintaining all the unique elements in a unique elements set. Now after that, we also have to find the minimum element. So minimum element would be the first element in the set, because set is always sorted, right? After that, we go over every element, every unique element, find the frequency of both of the element in both the baskets. If they are already equal, there is no issues. If they are not equal, we'll check if the difference is even or not, right? If it is not even, it means it is impossible, so we'll return -1. If it is even, we will check the frequencies, which like, or basically we will try to find out, we'll try to push the difference element in the diff array. So if f1 is greater than f2, it means the first array has more elements. So we will just push half of the element in the difference array, because this difference array is the array which contains the swaps. So in this particular case, the difference array would contain 333, and diff2 would contain 114. So that's how we built difference array. Now after this loop, we will have difference array. Now this is just a sanity check. This is not much required, but we have to now make crisscross pairs, right? So instead of making crisscross pairs, I just have reversed diff2, so that we don't need to make crisscross. We can just directly make pairs of I and I, right? After that, we just iterated over all the diff elements and taking the minimum across, swapping using a proxy or direct swap, right? And finally, we return that as an answer. So hope this solution makes sense. If you have any doubts in this problem, please post them in the comment section below. I would be happy to answer. Now coming to follow-ups. So there are multiple follow-ups. Firstly, let's say you need to minimize the number of swaps, right? So what is the answer? So that is that is one particular follow-up, right? That is very easy. Second follow-up could be uh, here we have said that we have to make the array equal after sorting them, right? So we are given the liberty to sort the array after making the swaps, right? Let's say we don't have that liberty, then what would be the answer? So you can think about these follow-ups yourself. The first one is very easy. Second one requires some thinking. So I would encourage you to think about it yourself, and we can discuss the possible solution in the comment section below as always. So hope you like the video. If you like, give it a thumbs up and do subscribe if you're not already. I will see you in the next one. Thank you.